Ever wondered what happens when you click an app or type on your keyboard? At first, it seems like magic, but your computer is actually a careful, coordinated machine. Let's break what happened. At a high level, a computer can be divided into two phases, a hardware and a software. A hardware is the physical component which you can touch, while a software is the program and instruction that tells the hardware what to do. These two parts communicate using the operating system, which act as a bridge between them. So to understand how computer work, we first need to know how hardware, software, and the OS work together. Let's start with hardware. Hardware can be defined as anything in a computer that you can physically touch or feel. A more precise definition can be hardware is a set of physical components and devices that perform computation, store data, and enable input and output operation in a computer. Simply put, hardware is the body of the computer, all the parts that make it real and tangible. Some example of hardware component are CPU, also famous as the brain of the computer, responsible for processing instructions and perform calculation. RAM for faster temporary memory that holds data and instruction currently in use. And GPU to visualize things and handles graphics and parallel computation. Storage devices to store the things as SSD, hard drives, SD card, and USB drives store data for long term. To take input from user from various sources as keyboard, mic, camera, microphone, anything that send data to the computer, and output device to give output to the user using various other hardware component as monitor, speaker, printer, anything that display or process result. Other component which can be included as motherboard, power supply, and cooling system, essential for connecting and powering everything. Hardware forms the skeleton and organ of a computer, but on its own, it can't do anything. It needs software to tell it what to do and the OS to coordinate everything efficiently. Once we understand hardware, we can move on to the software and operating system, which control and manage all these components. Now, that's we have covered hardware. Let's look at software, the instruction that tells hardware what to do. Software is any set of instructions that direct the hardware to perform specific tasks. Without software, hardware is just a collection of electronic components. It won't know what to do. There are two main type of software: application software, program used directly like browser, games, or video editor; system software, program that manage hardware and software resources of a computer, primarily the operating system. To understand software better, you also need to know APIs and system call. API, also elaborated as application programming interface. This is how software communicate with other software. We can define API as a set of rules, function, and tools that allow one piece of a software to interact with another. Contract that define how to ask for a service without worrying about how it done internally. As an example, currently you people may be using LLM like ChatGPT or other APIs key. Your app send a request to the model APIs and get a text response. You don't care about the internal ML algorithm. It's all hidden behind the API. Now, a syscall. A syscall is a mechanism through which software talks to the operating system to request low-level services, usually involving hardware resources. Example, in C, if you want to print hello on the screen without using higher-level libraries like printf, you can directly call the write system call. As you can see on the screen, here write is a system call. It tells the OS, please send these 6 characters to the screen. The OS then talks to the hardware to actually show it. In simple terms, syscalls are like the direct hotline from your program to the OS. So, till now, what we understand, API makes software modular and allow different programs to work together without directly handling the hardware or OS details. They let app talk to other app or services in a clean and reusable way. On the other hand, system call makes software portable and safe by letting program request low-level operating system services like file access, memory, or network without directly touching the hardware. They are the bridge between application and the operating system hardware. We have seen how hardware, software work together, but there's a key player in the middle that makes this possible: the operating system. The OS is more than just a bridge. It's a powerful manager that controls application hardware and all the resources in between, ensuring everything runs safely and efficiently. To understand how the OS works, we first need to explore its two main zones. First, user space and kernel space. A user space. This is where our application like live browser, game, text editor, and more runs. Program in user space cannot touch hardware directly. If they need something like opening a file, connecting to Wi-Fi, or displaying graphic, they must ask the kernel through sys calls in kernel space. This is where the core of the OS runs. The core of the OS is kernels. The kernel has complete control of the hardware and manage system resource. Key responsibility of the kernel are managed memory, to process scheduling which programs runs and when, or device control such as disk, GPU, CPU, keyboard, network, etc. Think of it as a security boundary. We can imagine user space apps are like employee in an office. The kernel is the manager with the master key. If an employee want to access to a secure room like hardware or anywhere secret data of the company are kept, they must ask the manager. Wait a minute. We had discussed about what is user space and kernel space, but how does actually kernel itself talk to the hardware? That's where device driver comes. A device driver is a special piece of software inside the kernel that acts as a translator between the OS and the hardware. Different hardware speaks different language. A printer, GPU, or Wi-Fi card doesn't understand the kernel directory, so the driver converts kernel instruction into signals the device understands. Without drivers, a computer would not be able to use most of its hardware. There is one more important layer which nobody talks about, that is ABI, Application Binder Interface. The ABI defines the rule of communication between the user program and the kernel. It decides things like how system calls are numbered, which CPU register hold parameter, how data structures are passed. Thanks to ABI, a program you compile on Linux will still run correctly on different hardware as long as ABI is consistent. You can think of it like a grammar rules in a language. Even if vocabulary changes like a hardware, the grammar ABI ensure that both sides understand each other. Well, let's combine them and understand. When software runs, it generally communicates in two ways. App to app, where user space only, communication stay entirely in a software. App to the hardware, cross kernel space, communication reaches hardware via the OS. Let's take the first scenario as app to app, user space only. The user app needs services from another program. Example, open a photo. It calls an API exposed by the other app or library. The request stay in user space. No syscall or hardware access is involved. The OS may assist with memory sharing or interprocess communication, but hardware is not touched. Example, a chat app want to display a photo. It asks the photo viewer app to open the image. If the image is already in memory or cache, the photo open without touching the disk. You can think of two employees in office talk directly using a shared playbook API. No need to involve the manager here, the kernel. Scenario second, when app needed hardware. How is the flow? The user app need hardware services. Example, read or write a file, draw on GPU, etc. It issues a system call, a formal request to the OS. The system call goes to the API, which makes sure that kernel understands it. The kernel receives the request and decides which subsystem handle it. The kernel calls the appropriate device driver, which knows how to communicate with the hardware. The hardware execute the section, example read/write, render graphic, etc. The result flow back up the chain from driver kernel to the app. When we are doing app-to-app communication, which is faster, lightweight, which is handled by the API, when we do app-to-hardware communication, it involves system call, ABI, kernel, device driver with hardware, ensuring safety, stability, and proper hardware control. If you enjoy it, then you will be amazed by our next video on what happens when you write a program in high-level language C++ and how it runs on hardware. Thank you.